yeah, I don't want to ruin too much of it. So anything else you want to say, Nick?
No, I mean, I'm over here in Tracy, so I'm more of a local, and I think I've been to GDG in person maybe 4 times now. So GDG Sacramento.
Sweet. Okay, so let's just go ahead and get started. So, how did this all begin? Well, I feel like a lot of these ideas, especially the best ones, they always start out in passing conversation, something you were not was not a specifically a goal, and that's kind of what happened with this whole game. So as we were speaking to each other with our team, we started talking about how there were some games that we could potentially recreate, and as we talked among our team, some potential candidates came up. There's a game called Drawful, which our team actually did, I think, a team game with, and we streamed it on our Twitch channel. And then there's another one that I really liked. It was called Scribble.io, and I've wasted a lot of hours on that game. But the intent was like concise enough, and it was basically a simple drawing game where a person could create a game, and in that one, a more advanced version, you would choose what you were supposed to draw, Pictionary style. So you'd choose something to draw, you would draw it as the host, and then other people tried to guess that game or guess the thing that you were trying to draw. And so when we were talking about that, we're like, we can probably build that. And that's what we set out to do. And just so you have some instant gratification, well, this is actually what we came up with pretty quickly, actually. There's obviously a lot more improvements that we could do to this, but we got it working, and that was really exciting for us. So you'll see here, the larger screen is kind of the person who created the game, or what we're going to call the host. And as they draw something on this canvas, this mobile phone mockup here could be a possible client, or maybe it was the other way around. I apologize. And basically, the host is whoever's drawing first, and then any clients that are added to that game would have those brushstrokes then propagated to wherever they were watching from. And we're going to talk to you today about how we went through this and how we built it. So, as we said, all right, this is awesome. We can probably do this pretty quickly. We still wanted to lay down some ground rules about what we wanted to do with this. And these were the ground rules. We knew that we wanted it to be cross platform. So, if we wanted to get more of our team playing with us, we needed to make sure that it was available for as many people as possible. We also knew that we wanted to use something familiar, right? I am sure that's the dilemma everyone has, is we don't want to learn something new, at least something that's so difficult that it almost just discourages us and makes us want to quit. So we wanted to use familiar tech that we both already knew and could just get up and running fairly quick. The next thing is that we needed flexible storage. So we knew that we needed to store some kind of data, probably some metadata about the game, a way to store the actual drawings, however that data would look like. And all of this, pointed to the fact, not just because we work for MongoDB, but the fact that we needed something flexible because we weren't sure yet what kind of data we would need. And finally, as the stretch goal there, or at least part of the bigger picture of this whole game, the essence of it is that you could play together, right? So as somebody is drawing something, it can't be laggy. It can't take a long, long time for those changes to propagate on any of the spectators. They need to be able to see it almost near real time, how you're drawing, so that if we implemented a timer, for example, they could see what is being drawn and guess in the appropriate amount of time. So keeping those requirements in mind, we built this game, and we'll show you how we did it.
Yeah, so we actually chose Phaser for this for a few reasons, but at the core, it's just a JavaScript and HTML gaming framework. So if you go to the next slide, Adrienne, perfect. Yeah, so Phaser uses HTML5 and JavaScript. We could have easily gone with Unity or another game engine, but it's familiar technology. We know JavaScript. Even if it's not our primary language, it's kind of like a common language that everyone on the team knows. It's also cross-platform, so it'll run anywhere a browser runs. So web, mobile, whatever platform has a web browser, it should work fine. And not only because it's JavaScript and we're familiar with JavaScript already, the learning curve to the actual framework itself, it's very easy to get into. So if you're trying to get into game development, if you're trying to break that barrier, it's very easy to use. So let's go to the next slide. So this is what it would look like if we were trying to use Phaser in our project. So if you hit the next slide, Adrienne. So on line 4, you'll notice that we are including the dependency of Phaser. So this could be something that you've downloaded. Could be something that you're using through a CDN. It's just a JavaScript library. So if you go to the next slide, Adrienne, on line 7, we have to create a container. So because when we load our web page, the Phaser portion of things doesn't load until after the page renders. So we need a container, so that way it's kind of like a placeholder for when our Phaser game is ready, then it could replace that container, which we're calling game. And then line 9 through 22. So now we've got our container. Now we need to configure Phaser itself. So for example, on line 10, we're saying phaser.auto. So we're basically leaving it up to the framework and the web browser to determine, do we want to use an HTML canvas or do we want to use WebGL? And regardless of what's chosen, that's kind of abstracted away from us as we develop. The parent on line 11 is a reference to that container on line 7, so it just has to match. Skipping over the scene portion, on line 22, we pass the Phaser config, and we'll be left with a blank, in this case, a black kind of 800 by 600 rectangle of a gaming space. So if we go to the next slide, now we want to talk about the scene life cycles events with Phaser. So go to the previous slide. Sorry, you skipped ahead. We look back at the scene portion on line 14. So there's an init, a create and update. There's also a preload. So the init is typically where you would initialize your variables. The preload, which we're not using right here, is where we would load our game assets. So that could be audio, that could be image files. This game being how it is, we didn't need any of that. Create is where we create the scene, like load our assets or just initialize stuff on the actual scene itself. And update would be a continuous call to our render function, which in the case, maybe we want to move something around on the screen. That would happen in the update function. So go ahead and jump 2 slides, Adrienne. So this is what we would have in our game right here. So we have a create scene and an update scene. Let's say that they go hand in hand with what we saw in that configuration. Starting with the create scene, what we're doing here is we're saying we want to create a new graphics object. That graphics object is going to represent what we can do with our lines, so our brush strokes. We're saying that our lines, they're going to be 4 pixels in size, and it's going to have a hexadecimal color value, which in this case is a shade of green. So we're going to skip over the update scene because we want to kind of understand how it works before we look at the code. So if you go to the next slide. So to draw lines with Phaser, at least for us, it wasn't so easy to understand at first glance. There's a little bit more to it than just saying, hey, draw a line. In Phaser, you have to understand how the lines work. So first of all, in Phaser, you're working with paths. So a path is any collection of points. The points in this path are defined by, in our game, the cursor location. And the point for that particular cursor location is determined based on our update function. So as updates happen, as the renders happen, the faster they happen, the smoother our curve is going to be because we have more points to connect the dots to. And this is all done by mouse down events. So if you go to the next slide, Adrienne, we can visit that update scene. So this update scene, the first thing that we're saying, is our pointer down? So active pointer is a reference to not only our mouse cursor, but if we're using a mobile device, it could be a tap event as well. So if our active pointer is not down, so it's up, and we are currently drawing. So this is drawing. Let's say that this is a Boolean variable. We're saying that we are drawing. So this part of the code, what we're saying is if we've just now finished drawing, so we were drawing because it was true, but our cursor is no longer down. And for now, it's going to evolve as we progress in this presentation. We're just going to say it's false. If you hit next, perfect. Otherwise, what we're saying is, you know what, is our cursor down? And if it's down, first thing we want to do is we want to see if we've just now pressed down on our mobile device or if we've just now pressed down on our cursor. Because if we've just now pressed down on it, hence is drawing is false, we need to start a new path. And we're taking the X and Y of our cursor, and we're saying -2. And the reason why we're saying -2 is because if you look back on line 3, our size is 4. And by default, the active pointer position, it's going to be at the corner of your cursor. And by saying -2, which would be half of our pixel size, we're now centering it in the cursor. And there's reasons why you would want to do both ways, but it's totally up to you. If we're not, so if we're already drawing and the cursor's still down, then we can just add points to the path and then just render them in the graphics object. Now, Phaser makes it easy for us to access what is composed in a path. So if we wanted to export our path to JSON, this is what it might look like. Now, in reality, if we have a very long line that's full of all twists and turns, our curves, there's going to be quite a few of them. It's going to be more than just this one entry in the array. But for any given brush stroke, we can say that that is our path. And you know what? When it comes to MongoDB, it kind of makes sense based on the format. And Adrienne's going to lead us into how we start working with MongoDB in this.
Sweet. All right. So again, of course, you could say it's only because we work for MongoDB that we decided to use this, but there really are some features that just made it much faster to get up and running with this, and I'll tell you why. The first couple things, though, is, you might even be thinking, well, why would you even want to use a NoSQL database in the first place? And there are several reasons, particularly for gaming, why it makes sense. So like I talked about before, we knew we needed a flexible data store. We knew that, or we did not know what kind of data we would be getting from Phaser, or how it would be formatted, or how we were saving those brushstrokes yet. And we also didn't know, at least in the beginning, before we started developing, what other kinds of data that we would be needing. So because we knew that this was going to be an iterative style of development, we needed something that could accommodate all of those changes. And this is something that's very indicative as well in the gaming industry. If you've seen games that have, seasonal campaigns, or they make, hopefully have some patches pretty quickly for bugs, they sometimes need that data store to be flexible. And for it to do that quickly, the flexible data store certainly helps. The next thing is that, our game is just a little tiny, little beautiful piece of proof of concept that is working right now. But let's say this has expanded, and think about all the other games. Like right now I'm playing Fall Guys game, and even though they had some issues before, I'm sure they're making use of this now. But when you think about games, they are full of really write-heavy tasks. So things like player updates, stat updates, if you get new inventory, if you are the player movements, leaderboards, there's all kinds of data that's being written all the time. And NoSQL databases are kind of built for this kind of write-heavy operations. So that is another thing that a lot of people don't think about when they think about why using a NoSQL database for gaming in particular. And then lastly, of course, mass and scale. So we're kind of joking, Nick and I, that I got that Fall Guys game when it came out, and they were having some issues, but they fixed it quickly. But we were like, we should probably reach out to them and see if they need MongoDB to help them get through those server issues. I don't know if someone actually did, but again, they have fixed those issues as of yet. I don't know if it was with MongoDB, but
Don't even know if they're using it.
Well, hey, you never
Never
know. And so specifically MongoDB, right? We offer all of those things, and we offer them specifically in these 3 ways. So I'm not going to read to you these things because these are kind of a little bit more salesy, but when you think about the scenarios of if you were developing for this kind of game, the agility, again, comes in with that iterative process. So if you need to change, especially if you come from a relational background, I know I did, and I know how painful it was whenever you needed to change the schema. Were your migrations correct? Did you run the scripts in the right order. There are so many things that could go wrong, and not only go wrong, but cause hiccups and cause blockers for that development to go through. So as we started developing new features, especially in games, you don't want those kinds of blockers. And that's one way that MongoDB helps, is because of that flexible data model. Another reason that this is super fit for games is the availability. So when we talk about availability in the context of games, there's nothing worse than like a laggy game or something that's crashing all the time, something that's not available, something where you can even get a game hosted, or you can't connect with your friends and have your party join in the same session. Those are all things that if you play games enough, that they're very much annoyances. They really ruin the experience of the game. And so when you think about this in terms of game development, of you being the game developer, this is something that could almost make or break your game. You want to be able to handle as many players as possible and have it be done in the smoothest way possible. It's the same when you have to patch particular nodes because you are experiencing issues there, or if you need to move some scale over. All of these things play a part as to why MongoDB Atlas specifically, because that's the cloud offering of MongoDB database, and how that helps in the availability of games. And then lastly, scalability. It's a buzzword, everyone has a different definition for it, but specifically for MongoDB, we actually have a lot of AAA titles that we're not allowed to talk about, but I promise you they're super big names, really big companies that are actually using MongoDB to help them scale. And when you think of scale, the first thing you think of is like, the game becomes popular overnight and you need a massive amount of resources to be able to accommodate the massive influx that you've just received, right? And so, yes, that's one way that we can help account for that. But there's also the less thought of version of scalability, which is, okay, let's say you've actually already peaked with your game. It's, maybe you don't want to think about that, but there are scenarios. This is a legit scenario where the game has peaked. Maybe your players are tailing off. If you had done this in the previous architecture, you may have spent a lot of money paying for all the resources that you initially needed to scale. But now that you're kind of dropping off, you've leveled and you don't need as many resources, you need that same flexibility to scale down so that you don't have to pay for all those resources. And this is indicative of most cloud services, but MongoDB is included in that. When you don't need that anymore, you can easily scale down and only pay for what you need at that time. And so finally, we go down to this path, right? Naturally, we're going to use MongoDB Atlas for our game in particular. We want the flexibility of the BSON model because we don't know what data we need yet, but we know we need it to be custom and flexible. We knew we wanted the scalability aspects of it because it is cloud-based. So if this ever grew, or our team took this on and upper management was like, yeah, let's just spread this everywhere, we can easily do that because we've already backed it on MongoDB Atlas. And then the last thing is something that I really like about it, which is as we continue to grow, and let's say we continue developing this game, there are two features here that are really helpful to kind of help keep you on track when you are developing not just games, but in any applications, really. So there's the Performance Advisor and Schema Suggestions. Performance Advisor, if you've never worked with it or heard before in MongoDB Atlas, is a pretty awesome tool that pretty much just alerts you whenever you have possible optimizations in your data that can occur. So as our game starts running, let's say we actually expanded and more players are playing on it, it will always occasionally sample some documents from our collections and see if there are any potential optimizations that could occur. If it notices that our reads are a little bit slower than average, or there is something that we, for whatever reason, did not index beforehand and it's taking a really long time, these kinds of things will be popped up to us, and not only will we be warned about them and told about them, but we'll also be told how to possibly fix them. So that's Performance Advisor. The schema suggestions is on a similar note there, but this focuses specifically on our collections schemas. So let's say there's some anti-patterns that we were developing because, we just need to get it out. We were just coding right away and we need to get to market and not even thinking about anything. I know we shouldn't do that, but it happens. Well, schema suggestions are another way that kind of help us keep on track and make sure we continue following best practices so that it doesn't bite us in the future. And schema suggestions, again, will lift up any anti-patterns that may be encountered from our data. So it will, again, like Performance Advisor, sample some documents from our collections. And if it finds that it does have an anti-pattern, we are implementing an anti-pattern, it will surface those as well and say, hey, you shouldn't be doing this. This is something that is not advised. And like one of the anti-patterns that's very common is having a document with, say, like 10,000 subdocuments in an array. That's an anti-pattern that's fairly common and something that we want to advise people against. So all of these reasons, we decided to go with MongoDB Atlas for our game. And so you'll see here in this GIF, so Nic showed us earlier what our data looks like that's coming from Phaser. And you notice that we'll have an object here with all of the points that we are sending from Phaser, because remember, we have points, XY coordinates that show where on the canvas that we have drawn. And this is what's great about MongoDB Atlas is we didn't change anything about what we were getting from Phaser. There was no manipulation on it. We were able to save it as is, and it just works. And it's able to be stored that way. We didn't have to think about it. It's going through. You'll notice we have a couple other little bits of metadata there, like the underscore ID and the owner ID, and we'll get to those in a moment. But the point here is that we got what we were given from Phaser, and we were able to immediately store it in MongoDB Atlas. And so Nic will take over for a bit to explain why this is important.
Yeah, so before we even get into how to go from Phaser to MongoDB and back again, I think it's important to take a step back and just figure out what it looks like to get data into MongoDB and out of MongoDB in general. So this is just a generic MongoDB query language query. You could run this from Atlas. You could run this from the CLI. You could run it from Visual Studio Code. Doesn't really matter. You can even run it from the drivers. But let's just say that we have a collection called game, and we want to insert one document. Now, this isn't going to be the true reality of what we would see inside of our game, because when we first start our game, there's not going to be any brushstroke data. But use your little imagination a little bit. We would insert an ID. This could be our game ID. It could be something that somebody can join to see brushstrokes that are happening. And then we would have our array of brushstrokes, which are just Phaser paths. So nothing too crazy right there. Next slide, please. Now let's say that we have a document in there. Let's say that we're still using that same ID. We could find a single document. So this would find the first document that comes back matching this ID. The IDs are unique, so it should only ever be one. But that would give us the same thing that we inserted into it, the ID, the strokes, and whatever else we might have passed along the way. The update is kind of where most of the magic is going to happen for this game. So let's say that we've created a game. This is more plausible. We've created a game. It has an ID that we've defined. It'll have other information as well, but it'll have an empty strokes array. So first of all, we're doing a match. So the first parameter here is a match. We're matching for any document that has that particular ID. Next. Then what we're going to do is we're going to use the push operator. So this is just one of many possible query operators that we can use. So what this is doing is it's saying push an object into the strokes array of our document. So in this case, we're just pushing a new path object. It'll push it to the end, and it doesn't matter if it's not unique. I believe there's a add to set operator that will add to an array, but it'll also check for uniqueness. but it's really not important for us for this example because it'd be very unlikely that we have 2 lines that are exactly the same. So we could just push them to the end. But this is more or less the type of stuff that we'd be doing inside of our game.
Sweet. So now we have a little bit about how we are interacting with our data, and we've talked a little bit about how we use that our custom language, which is MongoDB's language, MQL. And now we're going to get into how we propagate the changes to the clients that we have. And we were doing that using MongoDB Realm. So you may have heard about this before. It was called Stitch before, but ever since we've acquired Realm, we've kind of wrapped everything up in there. And so it's now known as Realm. So if you see any Stitch naming, just know that we mean Realm. So in particular, what did we use from Realm that actually needed to be used for our game? The first part is the authentication. So for our particular game, we needed some way to authenticate in order to work with our data in Atlas. And now for our game, since we were just wanted to get it up and running, we didn't need a too fancy of an authentication mechanism. In fact, we'll show you in a little bit, and we're showing here that we've just used the anonymous provider because we didn't really need to manage user credentials. Like we didn't want to have user accounts or deal with any kind of emails or passwords. We just needed that anonymous credential so that it can go through to Atlas. But you can if you wanted to. So again, if this game expanded and we wanted to offer accounts, that's also easily available. We just use one of the other providers like Google or even a custom JWT provider if we wanted to. So that is the authentication. Then the next thing that we knew that we needed to use are the rules. So these are some permissions that we can set at the database level. And we needed this because if you remember when I was talking about how the game functions, we have something called a host, which is the person that is creating the game and is the one who's able to draw. And then we have the spectators, who are the people who join the game and are watching. They're spectating. And the difference between the two is that, well, if you're the host, we want to make sure that you are the only one that is allowed to draw on the canvas at that time. We don't want any spectators being able to draw while you're trying to draw. That would ruin the whole purpose. Maybe a different version of this game would involve that, but that was not what we wanted for our game. We wanted it to be similar to Scribble, where it's one person drawing, everybody else is spectating and trying to guess what it is. So we use the rules that are part of the Realm SDK here, and we could set it to 2 different owners here. You'll see here we have an owner and we have a non-owner. So the owner is the host and the non-owner is the spectator. And we've set the rules to say if you are the owner, then yes, you are able to read and write your own data. But if you're the non-owner, you're only able to read. You can't write. So that helps us enforce those rules because yes, we can do them on the client side, but this is just an extra level of protection that's if let's say somebody manipulated it on the front end, it would still be checked at the database level. And then finally, there is sync. So we were talking about this, Nick and I, that what are the future versions of this game look like? Well, sync is something that's really cool in Realm. And what happens here is you can build an offline model or an offline first game. And we were thinking, we have a lot of colleagues that have either non-consistent or inconsistent internet connectivity, or sometimes, whenever we're traveling again, sometimes you don't have that connection right away. And so we were thinking about using sync in that you could maybe not for this particular game, but the point of sync is that you could interact with the app even while you were offline, and then once you resumed internet connectivity, Realm would sync all of that back up depending on what has already been stored. So these are all things and considerations that we thought of when we were thinking about our game, as well as any future renditions of this game. And so how do you actually add Realm to the game? We're talking about it. How do we use it? Well, just like we added the Phaser SDK via, I think we're grabbing it from their CDN here, or no, we have just the JavaScript file. We're doing the same with Realm. And yes, it says Stitch, but we mean Realm. And so we add it just as we do with Phaser. And when we add it, we now need to initialize a few things so that we can interact with our actual Realm app. The Realm app, the little GIF you saw earlier of us setting those permissions and setting the authentication provider, we need to be able to interact with that, and we do that with this code. So line 1 is just initializing the client, and in the Realm ID here, we would replace that with whatever Realm app ID was available in our cloud dashboard. And then here for lines 3 through 6, we're just initializing what database we're going to be interacting with. In this case, I think ours was called MongoDraws. And then the same thing, our collection, where we were actually storing all of the game data as well as the brushstrokes. The collection name was game. It's just game. Very simple. So all of this is just to get set up with our Realm application and to be able to interact with all of the things we've set on our Realm app.
Yeah, so that brings us into actual authentication with Realm. So kind of the heavy lifting that Realm does for us. So if we take an adventure back into our create saint function, you'll recognize lines 3 and 4, but you'll recognize that there's a few more lines here. So if we go to the next slide, on line 6, we're saying, like Adrienne had mentioned earlier in the slide presentation, that we're using anonymous authentication with Realm. We don't want to be burdened with any kind of username information or login. By using the anonymous authentication, all that we're saying is create a unique session for this particular client, give them a unique session ID, and then for however long that they continue to operate, that session will remain unique to them. So we're getting the credentials, and now what we're doing is, well, we need to figure out if we need to either join a game or create a game. So on line 8, what we're saying collection.find1. And if you're thinking this looks familiar, it's just a MQL query, so Mongo query language. So across all of the drivers that MongoDB has to offer, including Realm, you'll find that all of the APIs are the same. So in this case, we're saying collection.find1. We're looking for, in this case, a hard-coded game ID. If the result comes back as null, so it doesn't exist, that means that we weren't able to join the game. So now we have to consider creating the game. And when we create the game, we're saying insert 1. We're using that same ID. The owner ID, which we didn't show in its entirety, we only saw a really crude GIF image. But the owner ID, there's actually a rule behind it. So that's what determines if you're the owner of the document or not. So if we're creating the document, we're just saying that the owner is that particular authenticated session. And we're also saying that the strokes in this case is an empty array because there are no strokes to start with. So if we go to the next slide, this is more realistically on what we would see in our database. And we've seen some variations of this in a few slides already, but we have that ID. Now we have this owner ID, which is in this case just a hash value. We have our array of strokes, but really this is kind of a false because we technically don't have any strokes yet. We haven't done any saving after our drawing, but this is what it would look like. So let's go to the next slide.
Yep. Okay, so now we're almost to the end, right? We've gotten our game up and running in terms of the client side. So we are using Phaser to build that game. We are storing our data in MongoDB Atlas, and we are able to interact with it with our Mongo query language. So now how do we actually load those brushstrokes? How do we propagate the changes that we are saving to our database onto the actual clients, the spectators who happen to join our game? Well, we'll have to go back to our create scene function in Phaser, and we'll have to add a couple more lines. So we have to refactor it now to say we have to check now based on if it's a new game or if it's a game that we're joining. So keeping in line with how Nic was describing, if there is no result, we're assuming that this is a brand new game. We didn't find any documents or any games that had this ID, so we're creating one. But now for the rest of the information, so for strokes. So if we did find a game, well, then we would just set it to the actual strokes that were found, if it was available. Else we would still keep it empty. And it's the same with the owner ID. So if we did find a result, it did not come back null, then we would grab the owner ID from that result so that we would know that this game is already in existence and we would know who that owner is. And then again, if we didn't, we would set it to the current authenticated ID here. And then finally, to actually draw those brushstrokes, to load them in, we would just iterate through our strokes array. So same thing, hoping that we had some strokes here, or even it was empty, there'd be nothing. But we would iterate and go through and create a new path for every object that was in our strokes array. So we would create one using Phaser and then finally draw it, as you see here on line 20. And so this is what the update scene function now looks like, because now we also have to refactor this a little bit to deal with that fact of if we're using a game that's already been made, I'm sorry, no. So the first part, okay, so this part we refactored because we have to deal with if we created a game or if we're joining one. Now this one we have to update because we still need a way to continuously save any new brushstrokes that we are drawing. So in particular, what we needed to change here is this line here. We needed to add this. And just as before, so before we were finding one, we were using the find one command in our Mongo query language. This time we're using the update one to update this particular game with any new strokes. So first, it's our match criteria here, right? So the first object here is first try to find a document that matches this particular owner ID and this particular underscore ID, which in MongoDB, if we hadn't changed it and overridden it, would be a sort of hash object that's automatically created to help uniquely identify it. But in this case, we are overriding that with the game ID. So that's how we know which game is which. So we're finding a game that has these matching fields. And then once we've found that game, we're going to use our push operator to do the similar thing before when we created a new game. This time we're just pushing the new path into our existing strokes array. So that strokes array would continue to grow as we started to draw more, but that's okay. We're able to use it at that time. I don't think we've gotten to the point yet where it's an anti-pattern, but we got this running. So if it did alert us in schema suggestions, we probably somewhat changed it, but for now it's working just fine. So as we draw, we're using this query to continuously update our data and the brushstrokes.
So we saw how to load our brushstrokes when we first hit our game. We've also seen how to add new brushstrokes. But really where the magic happens is in being able to see these brushstrokes as they happen on multiple clients. And we're gonna have a demo, and everyone's gonna participate hopefully in this demo coming up. But a lot of the magic that we're gonna be working with is in change streams. And I know that we mentioned sync earlier on with Realm. We're not using sync here. We're just using change streams. They're a little different, but they accomplish similar things. So let's revisit this create scene that we've seen already. So let's assume that we have all of that other code for querying MongoDB, joining or creating a game, etc. Next thing that we want to do on line 5 is we want to watch a particular document for any changes that might happen. In this case, we're watching a particular document that matches the ID being whatever our game ID is. And in this case, it could be Adrienne Tacke game. So we could choose to watch on based on other fields. We could watch full documents, collections. There's a whole lot of things that we can do. But in this case, it's strictly one single document. Now, if a change comes in based on what we're watching, Well, we can loop over those changes, and it may be multiple changes depending on how many people are in participation. But we're going to loop over them. We're going to look at the updated fields. So which fields in particular were changed, and we could be looking for deleted fields as well if we wanted to, or new fields. But what we're interested in is updated. So we're going to loop over those updated fields, and we're going to add each stroke that comes in to our scene, just like we saw when we initially loaded that document. So it works the same. We're changing the variable name here because we don't want any kind of conflicts between data that's coming in real time versus what we're trying to draw on the screen, because then our dots could be mismatched. But there's other ways to solve that as well. This is a very easy way to get around it. It's not a MongoDB thing. It's a phaser thing. But all of this code, this is all it takes to get change streams working, and these are near real time updates on other clients. So I believe we have a demo, right, Adrienne?
Yes. How do we want to do this? Are we going to? We should let somebody create a game, and then I will join that game, and then we can all try to guess what they're drawing.
Yeah, I'm just pulling the URL so that way I can paste it in the chat.
All right.
And we do ask that whoever we're joining, please keep it safe for work. No no shenanigans here. So
right.
if you create a game ID, let us know what it is, and we'll join it, and we'll see what's happening.
You can see the our game, right, Nick?
Yeah, I see it on the screen.
Sweet. So if someone would like to draw, go ahead and create some kind of game ID, and then let us know in the chat what the game ID is, because then I will join it, and then we will all watch you draw whatever it is that we're going to try to guess.
And you could do this for mobile or desktop too. It doesn't matter.
Mm-hmm. Anticipation. I'm hoping to see
Yes.
a game ID soon.
Don't worry. If you're worried about your art being bad, it can't
yeah.
be worse than anything I've produced. So
that is a fact, actually.
Yeah. All right. So the game ID looks like Michael, and I'm assuming this is the capital M, because I think we didn't force a lowercase on anything. You're the host, so it can't be that one. Maybe it was with a lowercase m.
Unless my screen is too large, maybe. No.
Lowercase. Well, it says you're the host.
Oh yeah, that's right, because I can draw, so that's not me.
Yeah. So maybe just try it again.
Let's go back.
All good.
There we go.
There we go. It still says we're the host. Is there any kind of space character in there?
Whoops. Not us.
Silver rat.
All right, we'll try again, Michael. Just like that, right? Silver rat.
Yeah, let's try it. Oh, looks like somebody's drawing something.
It is the start of a rainbow.
Yeah, it could be. I think it's because you zoomed in. It's kind of wonky on where it's placed on the screen.
Is this going to ruin it if I zoom back out?
Probably. Yeah, you never know.
Oh, is this it looks like a dog? Is it a dog?
Possibly. Elephant. No?
It looks like a dog. I kind of want to move it over, but you can see it,
try
right?
Try to zoom out. You could be completely well, refresh it and go to Silver Rat again at normal zoom, and it should be pleasant this time. Because it's just doing that find one to start. Dog.
Oh, right.
All right, perfect.
Dog.
Well done.
Sweet. Got it. Oh yeah, it's at 250. All right. Who's next? Let me go zoom out a little. Sweet. Dog 2. Is that a guess, or was that an ID?
I think it was a guess.
Oh, okay.
I'm not sure though.
Anyone else want to draw? We'll try to guess it. Just put the game ID in the chat, and then I will go on there, and then we'll try to guess it.
We had somebody draw Spider-Man on our last stream, and it was pretty good.
That was the best one so far.
Is that Mac it dev?
I
Is that an
copied and
I?
pasted, but it says
Oh,
I'm
all
the
right.
host. So,
It's weird that your Zoom gets all out of whack too.
no. Here, let's do it this way.
Mac IT dev. There's
Wood
bugs.
spaces?
We definitely didn't polish it as well as we could have.
Is it wood spaces?
Copy
I'm just
paste, yeah, maybe.
I'm copy pasting it from the chat. Nope, says I'm
No,
host.
it's all good.
Here, how about you give me an ID, Nick? Go
Me.
on another one. Yeah, you draw.
Nobody needs to see my drawings though. Hold on.
Or you can share your screen and I'll draw, but I'm only saying that because I'm sharing my screen now. Anyone else,
So
you can still come in.
I chose GDG Sacramento, all lowercase, no spaces.
Sacramento.
I don't even
Good.
know what the hell I'm going to draw.
Well, you're on the spot now.
I know, right?
Sweet. All right, so we're not the host.
I'm trying to look around my office to see if there's something I can draw.
You can't do a leaf again either. That was too easy. It was too quick. All right, let's try. Guess in the chat what you think he's drawing. It is a rectangle. Knowing you, you're like literal.
Yeah, probably.
A mask. Nintendo Switch, Sam says.
Of course.
Nice. That's pretty good.
I forgot what it looks like over here. I think it's joystick down here and then buttons down here. This is with a mouse. I'm usually at my tablet and it's still bad, but you get the idea, right?
Yep. And so the face on my drawing is wonderful. And so, yeah, so that's the demo. We will take any questions now if you have any, and we'd love to clear anything up if we went too fast or want to go back to something. Or if you have another ID, we'd be glad to go up here too. So we have a question here. Nick from Sam says, why are no SQL databases better for write-intensive apps? So I kind of touched on it a little bit. Let me go back to my slide here. Actually, I can choose it here much faster. I think right here. So depending on how you configure it, this can be optimized for the write-intensive workloads. So yes, there's the scale aspect, which means you can have many more nodes or replica sets that can help you with the write loads. But there are also the I think the main point is the configuration of how much low latency you're willing to accept in the write operations for the database. So there are some things like write concerns that you can set for the databases that you set up. And these can be configured depending on the use case. So for example, there's something called write majority, where once a write operation goes to the primary database, you are expecting it to write to the majority of nodes before you're able to tell the client and successfully say it's completed, right? You are waiting for the majority of the nodes. Now you can, that's the default that's set because that's what we advise, but of course you can obviously change this depending on what your workload is like. Sometimes there are other write options of like write of one, which means as long as one node says it has successfully written it, then you can immediately return that it's successful. Or you can even go as far as to say write all. Was it all, Nick? Not, I don't remember what the all option is. Is it all or three or?
For the durability requirements?
Yeah, for the write concern. There is one that is you can do all. So depending on what you need, which is, do you need a rigorous data integrity that requires that you write to more nodes first before you have it, or is the data not as important, so you're okay to just get a quicker response, but there's less confidence that it is been successfully written to the other nodes, successfully replicated. So this configuration, at least from what I've spoken to with some of our gaming advisors, is that these things really help the game companies determine how they are saving their data and how they're interacting with their data. So it's that flexibility with how to configure it. Do you have anything I missed, Nic? Or do you have...
No, I think that's great. We have another comment in here. I don't know if I'd be comfortable answering it because I don't know much about Cockroach DB. But MongoDB replica set, I mean, if you want your data to appear on multiple nodes in a cluster, I mean, yeah, that's what a replica set is. Maybe I'm misunderstanding the question, or maybe I just don't know enough about Cockroach DB.
Cockroach DB is marketed as the distributed database. Can we say the MongoDB replica set to be something else? I know they have an offering that's similar to our MongoDB Atlas. So that is just the cloud version of our database. I don't know if it's, I don't know what their other products may be. But as far as that, those are comparable.
Yeah.
No problem, Sam. So Michael asks us, how long did it take for you guys to put this app together? Like,
didn't take that long.
Like a day?
Yeah, probably a day to get something working, and then whatever little bit of polish we added to it after that.
So that was, go ahead.
I was going to find the blog post to see it so that way you could reproduce it.
Oh, yeah. So Nic wrote a blog post exactly with that, and he has a repo too if you want to try it out yourself. It really was super simple. That was the whole point. We wanted to not get discouraged. We wanted it to get, we were really focused on just, we want to play a game. And so we needed something built pretty quickly. So that's why there's, so you can still see kind of some bugs there, like the screen not adjusting properly. Obviously, it could look a little bit nicer. And some future improvements we want to add are, again, similar to the Scribble game. So we want to be able to add a place that you can actually guess, right? Before, we were just kind of doing exactly what we're doing now. We get everybody on board. We'll say, hey, this is the game ID. And then we just kind of say on the Zoom call, yell out what we think it is, or in Slack. But that'd be nice to have it integrated in the actual game.
We're actually looking for ideas for our next project. We're going to do something in Unity this time around. Yes. So if anyone has an idea of something that's probably, don't tell us to create the next Final Fantasy game, but some kind of indie game that you think me and Adrienne can accomplish on just the two of us, we're looking for ideas before we start exploring Unity.
Yes, you might see a Twitch series starting soon.
Yes.
We'll leave the suspense.
Yeah, you want to show up the Twitch channel URL? It's in the slide deck, right?
Yeah, that's actually the last one. So first, thank you to everybody that came out and joined us today. We hope you had a little bit of fun with this and played around with this, but also ultimately learned that it's actually pretty simple to create a game. And fairly quick too. I know if you're like me, most people with game development, you're like, this is super scary. It probably takes a lot of work, but with some of the tools like the ones that we chose, it can actually be super simple. And then, yes, we are streaming. Right now, that's our goal. We've been pretty consistent with that. So we stream every Friday at 10 a.m. Pacific time. That's just go to Twitch TV/MongoDB, and you'll see that's actually me, Nic, and we actually streamed this building of this game as well. But we are actually streaming more often now. So be sure to follow us there, because sometimes we do stream on Wednesdays as well with other different topics. And it's not just game development either. It's using our drivers. It's how do you optimize your queries in MongoDB. It's some talks with some of our engineers on our teams on different products. So yeah, be sure to check us out on here.
But we're looking to do a lot more game stuff, right?
Yes, we want to. So, like, insider hint, you'll be the first, but we're going to try to start a series every Wednesday where you just learn with us. We want to try to create a game with MongoDB and Unity, and we're both new to Unity. Well, I'm new to Unity. Nic has some experience, but
I'm
we'll be
rusty.
relearning. So, yeah, we're going to be streaming the process of just learning something new, completely new, and hopefully we are going to build a game out of that. Awesome. So Marlon says he will tune in.
Awesome.
All right. Thank you, guys. That was great. Thanks a lot for coming and speaking at GDG Sacramento. And of course, you're welcome to come back anytime.
Thank you, Code Artist.
All right. Thanks a lot, everyone, for coming tonight. And see you next month for next meetup.
See you all.
Bye.
Thank you.
Do we stay on or do we just disconnect?
You can disconnect.
Oh, all right. See you later, everyone.
Bye.
Bye.